Hi guys, my name is Navkaran Singh and today we are going to see what is chi-square and how to solve it. So chi-square was introduced by Carl Pearson to distinguish whether an observed set of frequencies differs from a specified frequency distribution. Chi-square uses frequency data to generate a statistic. So chi-square is commonly used for testing independence and goodness of it. So testing independence determines whether two or more observations across two populations are dependent on each other, or in testing for goodness of fit, we determine if an observed frequency distribution matches theoretical frequency distribution. Moving further, you know, chi-square can be solved with parametric and non-parametric method. And in parametric method, we test for comparing variances, and in non-parametric method, we use it for testing independence and test for goodness of fit. 99% of the books and instructors use only non-parametric method. If we will search for chi-squares, how to solve chi-square, we will find only and only non-parametric method. Nobody use parametric method, or only few people use parametric method to test for comparing variances. Moving further, these are some of the conditions for the application of chi-square test. So number one is observations recorded and collected are collected on random basis. So all the observation must be collected on the random basis. And second one is all items in the sample must be independent. For example, if we are selecting this sample, and because of this sample we have to select this sample, so this situation must not be happen this situation must not be happen, like we have to select only independent sample. So number three is no group should contain very few items, say less than 10, or some statisticians take this number as 5. And number four, total number of items should be larger or at least 50. So the formula to solve the chi-square is sigma, number of observation minus expected frequency divided by expected frequency. And we have one question over here to to show how to solve the chi-square. So our question is, a personal director wants to test the perception of fairness of three methods of performance evaluation of 180 employees. 63 employees rated method 1 as fair, 45 employees rated method 2 as fair, and 72 employees rated method 3 as fair. And at the 0.05 level of significance, we have to determine that there a difference in perceptions or not. So as our data is like observed frequencies are 63, 45, and 73, and after adding them all together we will get 180. And to find expected frequency we have to divide 180 by 60. Divide 180 by 3, then we will get like 60 as the expected frequency. We will divide it by 3 because we have only 3 observed frequencies. And after that, like following the formula, we have to minus observed frequency with expected frequency. So it will be 63 minus 60, it will be 3. 45 minus 60, it will be minus 15, and 72 minus 60, it will be 12. And after doing square of all of 3, we will get 9, 225, and 144. And moving further, we have to divide these numbers. We have to divide these numbers with 60, like according to the formula we have to divide it again with the expected frequency, and we will get 0.15. After that we will get, if we will divide 225 with 60, we will get 375, and then if we will divide 144 with 60, we will get 2.4, and after adding them all together we will get 6.3 as our answer. Moving further, we have null hypothesis as all of the perceptions as same, and we have h1 as at least one perception is different, and our significance level is 0.05. And moving further, we will get our critical value as 5.991, and as our answer was 6.3, and that is greater than our critical value, so that lie in between this area, so we will reject the null hypothesis because it is our test statistic was greater than critical value, and our conclusion will be at least one proportion is different, like not all of them were same. So here we go, we got our answer, and moving further we will test of we we will do test of checking independence. So for checking independence, we have to find expected frequency in a different way. So the formula is over here: row total multiplied by column total and divided by grand total. So here is our data, and our null hypo. We will reject the hypothesis if there is no difference between Democrat and Republican in their opinion on the gun control issue, and we will never reject the hypothesis if there is an association between the responses to gun control and party membership in the population. As we have to find the expected frequency, so to find the expected frequency, we will use this formula as we talked before. So here is an example to find the expected frequency. So to find 13.9, we will take row total multiplied by column total and divide by grand total. So it will be 13.9, and we can find all the expected frequency with the same formula and with the same number. And moving further, we to find the degree of freedom, we will use the formula number of rows minus 1 and number of column minus 1. So that will be, we have like 2 rows and 3 columns, 1 2 3, and it we will get our answer as 2. So moving ahead, to find our test statistics, we will use we will use the same formula like the main formula for to solve the chi-square, and so to get the answer, we let me remove this mess from here first. So, so we will use the same method. So here is our observed frequency and here is our expected frequency. So observed frequency minus expected frequency divided by expected frequency, and we will add them all the six data things together, like all the observations together, like these six of them, 1 2 3 and 6. So after adding them all together, we will get 11.3 as our test statistics, and as our critical value was 5.9 only. So here was our critical value, and as 11.3 is greater than our critical value, so we will reject the null, and our conclusion will be Democrats and Republicans differ differ significantly in their opinion on gun control issues. So yeah, we got the answer as we will reject the null hypothesis. So thank you. I hope you guys found this video helpful. Thank you.